My name is Karim Ishakim bin Khairi.
And my name is Amirul Nazim bin Ma'ab Fadli.
My name is Wan Muhammad Scott bin Wan Muhammad Syakir.
Assalamualaikum warahmatullahi wabarakatuh. And hello guys. Today we will discuss about the application of determinant finding inverse using adjoint method. Adjoint method is a technique used to solve system of linear equation, a method that the concept of matrix inverse and determinant. Adjoint method can be applied when the system coefficient matrix is not square or when the determinant of the coefficient matrix is 0. How the adjoint method can be expressed? The solution can be obtained in the form of the transpose of its cofactor matrix, and the matrices can be done by find cofactor matrices and transpose cofactor matrix.
Electronic circuit design optimization used to optimize voltage levels at various nodes in complex circuits. It also helps in minimizing power consumption or maximizing signal quality by adjusting component values such as resistors, capacitors, and so on. Voltage sensitivity analysis determines how small changes in input parameters like resistance or current source values affect output voltage, and useful in designing stable circuits under component tolerance variations.
Purpose: to compute gradient of objective function efficiently with respect to multiple input parameters. To enable gradient-based optimization in system governed by differential equation. And third, to perform sensitivity analysis for identifying the impact of input change on system output. And fourth, to solve inverse problem by estimating unknown parameter from observed data. Fifth, to support data assimilation in forecasting models such as in weather and climate simulation. And 6. To reduce computational costs in a large-scale optimization and control problem.
Now, let's jump to problem statement. An electrical engineer needs to analyze simple circuit where the relationship between current and voltage at the 3 nodes for training purpose. He knows the input current at each node is 5, 0, and 4 before analysis are done. What he needs to know from his analysis is he needs to find voltage for each node. By using adjoint method, he needs to inverse the resistance in circuit to find voltage for each node. As for the solution, this problem statement also can write as AX equal to B, where A equal to resistance in the circuit, B equal to input current at each node, and X equal to node voltage. Given matrix A 3 by 3 equal to 4, negative 1, 0, negative 1, 4, negative 1, 0, negative 1, 3, and given matrix B 3 by 1 equal to 5, 0, 4.
The first step is to find determinant for A. So, 4 times matrix 4, negative 1, 3, minus in bracket negative 1 times matrix negative 1, 0, 3, plus 0 times matrix negative 1, 4, 0, negative 1. And we expand it, and it will be 4 in bracket 4 times 3 minus in bracket negative 1 times negative 1 plus 1 times negative 1 times 3 minus in bracket negative 1 times 0 plus 0 times negative 1 times negative 1 minus 4 times 0, and we'll simplify it and it will become 4 times 11 plus 1 times negative 3 plus 0, and the result is 41.
The next step is we need to find the cofactor for adjoint determinant A. So, the numbers in M represents the coordinate for the matrix. We look at the cofactor C11 is equals to matrix 2 by 2, 4, negative 1, negative 1, 3. To compute the value, we need to use the formula AD minus BC. So we will get C11 equals to 11. And then we use this method subsequently to find the remaining value. So C12 is equals to negative 3, C13 is equals to 1, C21 is equals to negative 3, C22 is equals to 12, C23 is equals to negative 4, C31 is equals to 1, C32 is equals to negative 4, C33 is equals to 50. And then the final answer cofactor adjoint determinant A is equals to matrix 3 by 3, 11, negative in bracket negative 3, 1, negative in bracket negative 3, 12, negative in bracket negative 4, 1, negative, negative 4, 50. And then we will get the answer 11, 3, 1, 3, 12, 4, 1, 4, and 50.
For the last step, we apply the formula. So, the formula is A inverse equal to 1 divided determinant A times adjoint A. And then we substitute the value and we will get 1 divided 41 times matrix 3 by 3, 11, 3, 1, 3, 12, 4, 1, 4, 15.
To obtain the result, we use formula AX equal to B. We move A to the right hand side and it will be X equal to A inverse B. We plug in all the information that we have and it will be 1 over 41 times matrix 3 by 3, 11, 3, 1, 3, 12, 4, 1, 4, 15 times matrix 3 by 1, 5, 0, 4. And we expand the matrix until we get the answer 1 over 41 times matrix 59, 31, and 65. We equal it with V1, V2, and V3, which we will get the answer 1.44, 0.76, and 1.59. Therefore, the total voltage for each node we get is 1.44, 0.76, and 1.59.
So, we come to the end of the presentation, which is our conclusion. Based on the problem statement, we can conclude that using adjoint method is much easier than Cramer's rule. By using the adjoint method, we can find the value of voltage X, Y, and Z from the problem statement. We have determined the voltage of each item circuit. By that, we have successfully reached all the objectives in this case study. The thing that we learned today is the adjoint method is a systematic technique used to compute the inverse of a matrix. This method can be applied in real-life applications such as electrical circuit analysis. So, customers can make option before buying an electrical circuit for their daily life.
That's all from us. Thank you.
Thank you for watching.